we're live. Okay. So solving rational equations. So the radical equations, like I said, we're going to go over Thursday. So we have fractional equations. So what we want to do here is, the first thing you always want to take into consideration is the domain. Okay? So that means that we want to take a look at the denominator and determine where the denominator will equal 0. So if we look at this first one, A, we have x plus 4 over 3x equals 1/2. So the 3x, because there's a variable in it, what value could I put in for x that would make that 0? 0. So that means that we have to recognize that x cannot equal. Because if one of my solutions is 0, it's not going to work. It's going to make it undefined. All right, so that's something you want to check before you start the problem. Because by the time you get to the end, you'll have a solution or two, and you say, oh, there it is, I'm done. Okay, but we always have to go back and check. Now, it says here, option 1, clear the equation of all fractions by multiplying both sides by the LCD of all fractions in the equation. Option 2, get one fraction on each side of the equal sign, then cross multiply. So if you can, it'll be easiest to get one fraction on each side and then multiply. So since I have a single fraction, we just have to cross multiply. So we have 3x equals 2x plus 4. This equals, it doesn't matter which goes on which side. So if I had the 2x plus 4 on the left side and the 3x on the right side, no big deal. So then it's just a basic algebra. Distribute the 2. I have 3x equals 2x plus 8. Bring the 2x over. I have x equals 8. Okay? And of course, you can always check. All right, x equals 8. So if I put it back in the original, what's 8 plus 4? 12. 8 times 3 is 24. 12 over 24 is 1/2. So your solutions should work. Okay? Same thing with fraction. Which one of the fractions have a variable in the denominator? Both. Okay? So in the first one, my domain, x cannot equal what? 2. Okay? Because x minus 2 equals 0, x equals 2, we'll make that undefined. In the second one, the 6 over 2x, x cannot equal 0. Okay? Because that makes it undefined. So then single fractions on each side, again, cross multiply. I have 2x equals 6, x minus 2. X equals 6x minus 12. I don't care. You just have to be very side. 4 left on the right side. Negative 12. Yeah, don't lose that. Minus 12. The negative 4, and I get x. Okay? Check and check. 2, 1 over 3 minus 6 over 3 times. Remember, you can only multiply on. Okay? So what do we have here? We have a 12, and I need a y. If you wanted to multiply on by 4, you could, and you would get the 48y. That's fine. That's not the least common denominator. That's just a common denominator. And then you go through it, and things will cancel. You'll still get the right answer. Okay, so if that happens, you're doing something, and you get a different common denominator, that's okay for the most part. Okay, as long as you did correct mathematical computation. So once I have this least common denominator, you are going to multiply every single fraction by your LCD. Okay? So if I have 12y times 112, it's technically, and I'll show you this the first time. I'm not going to show it every single time because we're going to get a little quicker to cancel. It's going to be 12y over 12 plus 12y over y equals 12y over 4. That's essentially what's happening. Okay? Does everyone see that? So then what you want to happen is all the denominators will cancel and be gone. So these 12 cancel, I have a y plus. These y's cancel, I have a 12. And then these, it looks like a y, but it's not. The 12 cancels with the 4 to give me a 3y. Okay, does everyone see how that happened? So now you have a basic algebra problem. Bring the y over, 12 equals 2y, divide by 2, y equals 6. Okay, yes, go back and check. Also, make sure that it's not one of these right here, where it doesn't equal. Okay, we haven't seen it yet, but we will. Okay? Next one, same thing. You have multiple fractions. So if you want to find the LCD, tell me that x cannot equal what? 0. Okay? My LCD, what would be my LCD? 18x. Good. Okay? So 18x. So remember, you're looking for the least common multiple of 6 and 9. 6, 12, 18, 9, 18. So there it is. Again, if you went to 36, no big deal. Okay, just makes it a little more difficult. And then you have to represent the x. So now I'm multiplying everything by 18x. Okay, so if you need to write it like I did over here, then go ahead and write it all out as a fraction. Okay, but we want to get to the point where we don't have to do that. So 6 will cancel with the 18 how many times? 3. I'm left with a 3x plus. The x will cancel with the x, so I have an 18. Okay, the 9 will cancel with the 18x and give me, and that's fine. If you want to do 4 right off the bat, that's okay. Okay, I just showed that too, just not to lose you. But yes, you should be able to go right off the bat and get that a 4x. So 3x plus 18 equals 4x. Bring the 3x over, and you have x equals 18. Okay, can't equal 0. That's all good. No problem. All right, good. That's the basic introduction. So that stuff should have been pretty good, right? So now, a little more complicated. Okay, a little more complicated. So first thing you have to do, okay, is consider your denominators and where they will be undefined. So I have x squared plus 5x. How do I find where that is undefined? What do I do? You're going to, but ultimately, you're absolutely right. You're going to factor the x out, but it should be equal to 0. Okay, that's what you want to do. You want to find out where it's equal to 0, because that's where it will be undefined. And then you're right. You factor out the x. Oops, put the parentheses in the wrong spot. So then I have x equals 0, x equals -5. Okay, so that's where it equals 0. Therefore, x cannot equal 0, x cannot equal -5. Okay? And that, exactly. So this helps you when you're looking for your LCD, because this x minus 5, oh, it's already here. This x, oh, it's already there. Okay? So this factor to x plus 5. So when I'm finding the LCD, you have to make sure that every single denominator is represented in the least common denominator. So I have x plus 5. That'll take care of this first one. And then the x plus 5 I already have, and the x I already have. You don't have to show them twice. If you show them twice, again, it's just going to be more difficult. They will eventually cancel, but it's going to be a lot more difficult to solve. Okay? So you got your LCD. Every single term gets multiplied by the x plus 5. So in the first term, the x and the x plus 5 cancel. So you have 3x plus 5 plus. Now this can be a little more difficult to do in your head. You got that x plus 4. Okay, don't lose any of the numerators. The x plus 5 cancels with the x plus 5. What am I left with? X equals x plus 1. Okay, this x cancels with the x. What am I left with? X plus 5. Okay? So this is now they're getting a little more involved. All right, so what do I have here? I have 3x plus 4x. If you need to box that over on the side, that's fine. You got x squared plus 5x plus x plus 5. Fine. And then you get to the point 2 where you can kind of do this in your head when it's, you know, a little more basic problems. All right, the middle 2 terms, the peanut, remember? You should be able to do that in your head as you proceed. Okay? Combine like terms. So and put them in descending order because it'll help you. All right, so the left side I'm going to rewrite as x squared plus 7x plus 5 equals x squared plus 6x plus 5. Okay, go down and solve. It sometimes looks weird. All right, so what happens with the x squareds? They cancel. That's okay, it can happen. All right, now I bring the 6x over. I'm left with a what? Just an x. What happens to the 5s? Cancel, so I have x equals 0. Okay, so x equals 0. Go all the way back up here. Oh, what can happen? Okay, can't have it. All right, so therefore there is no solution. No solution. Okay. And then the last one. So what I do underneath is I factor every single one that can factor. So I'm taking a 4 out of here. I have an x plus 3. I have an x plus 3, x minus 3. And then the x minus 3 can't do anything with. Okay? So now sometimes it might be easier to find the LCD and then find where it's undefined. Because you don't want to set each one of these denominators equal to 0, because then you're getting repetition. Okay? So my LCD, what do I have to have? I have to have a 4. Okay, because every single thing needs to be represented. I have to have an x plus 3. Yeah, and then I already got the x plus 3, so I also need an x minus 3. And then I already have it. Okay, so again, don't have to show it twice. Okay, is everyone good with that? So now you got your LCD. So now we'll come up over here and say, okay, I have 4, x plus 3, x minus 3 equals 0. Divide both sides by 4, hypothetically, so that's gone. So then this is x equals negative 3. This is x equals 3. So therefore, it can't equal negative 3, can't equal 3. Okay, because that's where it will be undefined. Does that make sense? Everyone good? All right, so every single term is multiplied by 4, x plus 3, x minus 3. So the first 2 are 1s in the numerator, so a little easier. So what will cancel? The 4 will cancel. The x plus 3 will cancel. I am left with, what's that? Yep, x minus 3 plus. I have x squared plus 9, so I have x plus 3 cancel. X minus 3, I am left with 4 equals, you got that 5, and x minus 3 cancels. I'm left with 4 and then x plus 3. Okay, just be very careful. If you want to send it through and have 4x plus 12, that's fine, no problem. Okay, whatever you want to do. Everybody okay with that? Good? Okay. So now, combine. So I have x plus 1 equals. So this right here is 20. Okay, 5 times 4 is 20. So I have 20x plus 60. All right, doesn't matter which side goes where. I usually move the smallest x just to make it easier on myself. So then this becomes 19x. This is negative 59. It's okay to get some ugly numbers. You're in pre-calc. Okay, not everything's going to work out evenly. So then you divide both sides by 19. Divide both sides by 19. I get x equals negative 59 over 19. Okay? Does that make sense? So what I'd like you to do, and it's going to take a little while, I'd like you to take this value, and I'd like you to plug in the original equation, the entire thing in your calculator, and then such that x equals negative 59 over 19, and get it to say true. Okay, so it'll take you a couple minutes.